Hello Physical Science, this is Mr. B, and we are going to start our last section of Chapter 11, and the title of this section is Acceleration. So this is going to be kind of our last little tidbit about motion. We've talked about distance, we've talked about displacement, we've talked about speed, we've talked about velocity. Kind of now the last little piece to introduce motion now is acceleration. So and we're just going to kind of jump right into it with our little example, kind of how it starts each section here. And the example they give, close to my heart here, is basketball. And says the basketball constantly changes velocity as it rises and falls. So again, she's dribbling the ball, she's shooting the ball. The ball's velocity is constantly changing throughout the course of a game, anytime anyone's playing with it. And describing changes in velocity and how fast they occur is part of describing motion. And those changes in velocity, as we're going to see here, is really what acceleration is going to be. So I'm sure you guys have probably all heard of acceleration at some point in time. Now we're just going to get an actual definition for what acceleration actually is. So I would definitely write this down, and it is the rate at which velocity changes. So remember, velocity is the combination of the speed, how fast you're moving, and what direction you're moving in. And so now acceleration is going to be described as how velocity changes. And we can see here that, again, I was going to get a little bit ahead of myself, so I figured I better just change over to the next one. In science, acceleration applies to any change in an object's velocity. That means it can either be a positive or an increasing change in speed, or a negative or decreasing change in speed. So the name that we have for the decreasing is deceleration. So you've probably heard it like this. Deceleration is an acceleration that slows an object's speed. So kind of the easy way to think about it to help you remember the difference, I mean, you've probably heard both the word acceleration and you've probably heard deceleration before in your life. How I remember is acceleration, you're speeding up. Again, you accelerate in a car. That's what everyone usually associates this word with. It means the car is increasing in speed. It's increasing its velocity. Deceleration, you're just slowing down. It's the decreasing change in speed. So you are not having as much speed. You're not having as much velocity. So technically, again, when you slow down and when you speed up, those are both technically a type of acceleration, but just to be a little more clear, we can say deceleration for when you slow down. So that's all acceleration is a change in your speed, therefore a change in your velocity as well. And another term to kind of, again, make this a little more scientific, maybe something you haven't heard as much besides acceleration, deceleration, is free fall. And that's the movement of an object toward Earth solely because of gravity. So without any other forces acting on it, if you just drop something from the top of a building, it is in free fall because there's no other forces acting on it besides gravity at that point. So free fall, I would definitely write down what free fall is. It's the movement of an object toward Earth solely because of gravity. That means gravity is the only thing that's affecting it. It's not being influenced in any other way. And the unit for velocity is meters per second, which we went over in our last one, on our last section there. And so the unit for acceleration then is going to be meters per second, and that's typically written as meters per second squared. And another important piece of information I would write down to kind of go along with this is that objects falling near Earth's surface accelerate downward at a rate of 9.8 meters per second squared. So no matter what you are, whether you're a rock or a feather or what, you are going to accelerate at a rate of 9.8 meters per second squared. That's how all objects fall at. That is the force of gravity that acts on them. Again, no matter what you are, that's how fast you fall. Again, things like how much mass you have might influence how quickly maybe you reach that point, but this is the constant rate of gravity acting on any object, is 9.8 meters per second squared. So that's an important number right there. Again, that's just the natural effect of gravity, 9.8 meters per second squared. And then just to kind of put that into a little example here, is that each second an object is in free fall, its velocity increases downward by 9.8 meters per second. So you can see the change in the stone's speed is 9.8 meters per second, the acceleration due to gravity. So again, to give this a little bit, again, these things are a little bit easier to understand when we have an example. So our time is 0, our velocity is 0 meters per second. The stone has not yet started moving. So when we drop the stone at 1 second, we measure its velocity. It's 9.8 meters per second. So after 1 second, 9.8 meters per second, that's exactly what we would expect. And then after 2 seconds, its velocity is now 19.6 meters per second. And I'm no math major, but I bet if we took 9.8 times 2, that's the answer we would get right there. And then after 3 seconds, we are now at 29.4 meters per second. Again, because that is how fast the stone is falling. And again, it's kind of hard, like I said, to explain some of these things over video. So we'll explain this more in class to make it a little bit easier to understand here, because again, it's just kind of hard to explain over video. So remind me, we'll go over this stone example in class to make it a little more easy to understand. And just to kind of add some more onto acceleration, is it can be a result of change in direction at a constant speed. So for example, riding a bicycle around a curve. So even though your speed is not changing, when you're riding the bike, so your bike, you could be riding down your street at 5 or let's say 15 miles an hour, and you might not hit your brake at all as you go around a steep curve. You still keep your speed at 15 miles an hour, but you are still changing your acceleration because you are changing your direction. So if you change your direction, you change acceleration. If you change your speed, you change acceleration. So acceleration is not limited to just a change in your velocity. It can also be a change in your direction as well. So the example here, another one, is a horse on a carousel. It's traveling at a constant speed, but it is also accelerating because its direction is constantly changing. So don't get confused, or don't be limited to the fact that acceleration is just based upon on your velocity. It is also based upon your direction as well. And then again, sometimes you can also do them both at the same time. So sometimes motion is characterized by changes in both speed and direction. So passengers in a car moving along a winding road experience rapidly changing acceleration because there's different curves, there's straightaways, you're going to have to slow down, then you're going to have to speed back up. You're constantly changing direction. And then the car may enter a long curve at the same time that it slows. So therefore, the car is going to be accelerating both because it is changing direction and because its speed is decreasing. So they're just really, with these last couple slides, trying to drive home the point that acceleration is not just based off of speed. It is based off of direction as well. And then again, a roller coaster is a good example because you're changing both speed and direction. To wrap this one up, we're going to talk about one more specific type of acceleration. It's called constant acceleration. So I'd make sure I wrote constant acceleration down somewhere. And that's the velocity of an object moving in a straight line when it changes at a constant rate when it's experiencing constant acceleration. So it's just a steady change in velocity. So it's basically like a predictable change, like you're moving up at steady increments. It's not just like a rapid, like all of a sudden I'm going to increase 30 miles per hour and then slow back down. It's like a steady increase of about maybe 3 or 4 miles per hour over a long period of time. And the example that they give is an airplane's acceleration may be constant during a portion of its takeoff. So if you've ever been on a plane, it's not just like all of a sudden you're constantly stopping and starting and changing direction. No, you stay in one straight line when the plane's taking off, and you don't just jump speeds. You don't just go from stopped to all of a sudden you're up in the air flying. No, you have to kind of build your velocity up at a constant acceleration. And then they just say, to wrap it up here, that constant acceleration during takeoff results in changes to an aircraft's velocity that is in a constant direction, which I already said. So that's it for the first part about just kind of introducing acceleration. We're going to do some problems with acceleration in our next video and the next day in class. So make sure you let me know if you have any questions.